Hello guys, welcome to Exam List, and in today's lecture series we will explore the connection of commutative relation with Heisenberg uncertainty principle. Now before that, let us take a quick review of the notation we have learned in the last lecture. So if you have an integration minus infinity to infinity, okay, some wave function psi, its conjugate, and say there is an operator x, and this operator x is acting on psi. Okay, so you see this integral is nothing but expectation value of x. So this can be written as the Cat-Bra notation as, so this will be psi. So, and since x is acting on psi, either you write x psi here, okay, or you can also write it as keeping the x in between, but that too would mean that the x is acting on the psi, that is towards the right. Agreed? This is the notation. However, if the x is acting on psi star, so for example there is something, some operator x, okay, so let us not write it x. How about some arbitrary operator? Let me use omega, some arbitrary operator omega, okay, it's acting on psi star, and the integral is from minus infinity to infinity. Okay, it is acting on psi star and psi, and that is a dx. Okay, now this type of integral is written as in the Cat-Bra notation as this omega operator acting on psi star. So both omega and psi are on the bra side, and this side we have our psi in the cat side, which is the real one. I mean the one with not with the conjugate. Agreed? Now an interesting thing about the operators in quantum mechanics is that, so this is equal to this. It means it is same as omega acting on the bra or omega acting on the cat side. It is same. So these type of operators are called as the Hermitian operators. Agreed? So all the operators in quantum mechanics are actually Hermitian, and all the operators in quantum mechanics, they satisfy this fundamental postulate. Okay. So this is called Hermitian operator. Hermitian operator are the operators that satisfy this particular relation that is kept in the bracket. So not going further, what we do is we are now going to prove the relation of how the uncertainty principle is related to the commutator relation. So let us do that. Okay, so how to start with? We start as follows. Now there are two ways to start actually. Either you assume this is true and you prove this, or you assume Heisenberg uncertainty is true and you prove this. So road A is assuming the commutator as true and proving the Heisenberg uncertainty principle, and road B is assuming the Heisenberg uncertainty as true and reaching the commutator relation. We will follow the road A. Okay, we will assume from the very start that the commutation relation is there. Okay, and then we will try to prove that using this commutation relation we can actually reach the Heisenberg uncertainty principle, and that derivation will indirectly prove that both the commutation relation and the Heisenberg uncertainty principle are the same thing. So let us start our proof. So what to do first? So consider the product, uncertainty product, that says that any uncertainty in position, take a square of it. Okay, and if there is an uncertainty in momentum, and take a square of it. Okay, this will be equal to as this. Okay, just let me remind you. So what is uncertainty in x? Okay, so uncertainty in x was the x minus the expectation value of x. So this was the uncertainty in the x. Agreed? And we were actually taking the square of the entire term. Okay. So square of this is square of that. Now, okay. So remember this. So when you were calculating the expectation value of x, how did you write? You made this, I'm writing in cat bra notation. You take psi and sandwich the x in between two psi's, one in cat and one in bra. Okay, this is how you are writing. Now, if you are asked what is the expectation, what is the uncertainty in x, please see that when you wrote this thing was also written in a different form, if you remember. So this was written as uncertainty in x was equal to root over of, okay, expectation value of x square minus square of expectation value of x. Agreed? Please see that these are operators. These has to be acted on the psi. So uncertainty in x is calculated as in this manner. So if you are given psi, then put a psi here, put the value of operator. So what is the value of operator? That is x minus expectation of value of x, square of it, and then put the other psi here, and it will be root over of the entire stuff. So 1 by half at the top. Agreed? So try to understand, these are operators and operators need to be acted on psi. This is how things are calculated. Agreed? In this way, if you have understood these two things, then we can continue with this. So look at the uncertainty product here, the product of uncertainty in position and uncertainty in momentum. So how do we write that? We write as follows, as this. Agreed? Now what we can do is we need to simplify things. So what we do is we introduce two notation here just to simplify things a bit. So instead of writing this big term again and again, so they introduce a notation. So say x tilde. Okay, this is different. Okay, this has nothing to do with expectation value or something. It is just a representation of this particular operator. So x minus expectation value of x. So let it be x tilde. And another notation that I would like to introduce is p tilde. So that will be p minus expectation value of p. Agreed? So this is how things are treated. So what will happen? This will actually simplify things a bit. So this thing can be simplified as, and it can be written in a very simple way. So it will be psi. Okay. So this will be x tilde square, x tilde square, and psi. Similarly, the other term will be okay. And we know that by the Hermitian property of the operators, this thing can be written as x tilde psi and x tilde psi. Why is that? Because the x tilde psi on the left will anyhow move towards the right. It doesn't matter because things are, the operators are Hermitian here. Agreed? And this can be easily written as p tilde psi, and there will be a p tilde psi. Agreed? Okay, this is just what we have written. Now what we'll do is we'll introduce the Schwarz inequality. So what was Schwarz inequality? So let me write the integration form of Schwarz inequality and then I'll write the operator form. So that will be easy for you. So this was Schwarz inequality that we have studied earlier, and how to write this in the cat-bra notation. So this will be written as this. So F conjugate means F will be on the bra side and G will be on the cat side. Okay, that equals to, so this can be written as mod of f square. Okay, mod of f square means the imagine the integration is already there and there will be f star f, and this will be mod of g square. Agreed? So this is your Schwarz inequality that you have studied. So what we will do is we'll use this Schwarz inequality to write this relation. Okay, this relation can be written as, so this will be written as, okay, so we have to write it small, we lack space here. Okay, so this is how it will be written. I've written it down here. So look at this relation carefully. Okay, all we have done is we have used the Schwarz inequality. That's it. That's all we have done. Now we will move from here. So assume this is same as the last part. Okay, so we will move on from here. So I'm trying to erase everything, and we'll move on from this part. Okay, now you can easily write, so these two product of operators can be easily mathematically written in a different form. So let me write it here. Okay, so once you have written in this form, then things become very simple from here on. So this part can be now written as, okay, so I left in a 2 here, the square part here and a square part here. Agreed? Now everything is okay. Now this one is actually written in a another style, so that is x tilde, okay, comma p tilde. So this is anti-commutative relation. So in the anti-commutative relation, there is a plus sign here, and this part is the commutative relation. So forget the so keep the half here, okay, and the second part is keep the half outside, and the second part is the commutative relation between x tilde and p tilde. Agreed? So now we can write the entire relation as, okay, so what will happen now? So this will be greater than equals to, okay, so so this part, okay. Now if you consider this second term, okay, in the second term we know that x tilde and p tilde gives you I h cross. Okay, so what will happen here? So this term will become 1/4, I h cross will come outside, and you will be left with psi bar cat and bra psi square. So this is nothing but probability, and we know that probability is always 1. So total probability is always 1. So we are left with only I h cross by 4, and this I h cross will be in square. Okay, see, the I h cross will be in square. So